All right, and welcome to Unit 5 on circular motion and gravitation, lesson number 3, vertical circles. Now, this lesson is going to talk about an object that's attached to a massless rod, and it's going to be spun around in a vertical circle with a period of 0.72 seconds. This question says if the minimum tension in the rod is 20 newtons, we need to determine the length of the rod. The length of the rod is going to be the radius of our circle. Okay, and so I've kind of sketched out here a little scenario that this explains, right? We have this is our massless rod. This is going to be like the center, the pivot point that this is connected to, and this is going to spin around this circle. Okay. The question also tells us that we have a period of 0.72 seconds. So the spinning action for this mass to spin around and return to its starting position again is going to take 0.72 seconds. It also tells us the minimum tension in the rod is 20 newtons. So this is going to get into a little bit of backstory on this lesson. The first part of this is called minimum and maximum tension. And really what we're talking about is you can imagine if you're spinning, say, a bucket around on a string, when that bucket is at the bottom of the swing, so when that bucket is down here, we're going to be experiencing the most tension in the line and therefore the most weight on our hands. All right, that's largely because we can think that in circular motion, our acceleration's upward, which means our net force is upward. So F net, which is positive, which is our acceleration value, is going to equal, really we have here force tension up and we have force gravity down. So we could say force tension minus force gravity because force gravity is down. And if we rearranged this, we're going to end up with force tension, I'll make that an F. Force tension is equal to F net plus force of gravity. And the tension is the force that we're feeling with our hand. It's the one connected to our hand at the center here. So we are going to end up with that force net value plus force of gravity. So it's an addition of forces. We can compare that to, let me back this off a little bit here. We can compare that to the top of the swing. And, looks like I'm one back short of being able to erase it all. Okay, at the top of the swing here, we can say that it's going to feel the lightest. And you can probably imagine that. If you're spinning an object on a string, it's almost massless at the top. In fact, if you go too slow, it just falls. Okay, so at the top, the book shows it in a little bit of a different way. They're showing that in this case, down is going to be the positive direction, because that makes things much more convenient. Okay, so negative is going to be up, positive is going to be down. Keep in mind for when we were doing max weight at the bottom of the string or max tension at the bottom of the string, we had normal convention. We had up was positive, down was negative. All right. And so what they do is, since down is positive, right, our acceleration, so our F net is going to be positive, and it's going to equal the sum of all of our forces. Well, force gravity is down, so it's going to be equal to force gravity. And since down is also positive and tension is down, also force tension. And when we rearrange this, we end up getting, force of tension is equal to F net minus the force of gravity. And so really the gravity here is adding to the bottom and being subtracted from the top. That is why the tension force feels less when this object's at the top. All right, anyways, getting back to this question, the question mentions that the minimum tension in the line is 20 newtons. Well, to me, the force of tension being minimum indicates that it's at the top. The bottom would be the maximum. Anywhere else would be some angle in between, which thankfully we don't really need to get into in this course. All right, but know that you could do it. All right. Now, let's set this question up. So just like we had a moment ago, I'll switch my colors up. We said that the net force, so F net, is equal to mass times acceleration. And I actually just jumped right into, well, in this case, it's AC. And in it, what I just did is I combined them. And so we also know that F net is the sum of the forces. So F net is equal to, in this case, let's make, positive down and up negative. It's going to make this question work much more conveniently. Okay, F net is equal to force of tension. Force of tension is down, and in this case, we're saying down is positive, although you don't always have to do it. It works out if you have positive up and negative down. Okay, and plus the force of gravity, because gravity is also in the downward direction. All right, so here we have force tension. We also have force gravity. And our acceleration, I'll put that one in the center here. Our acceleration is also towards the center of the circle. So all of our forces are in the same direction. Okay. So what do we realistically want to find? If we're going to be doing some formula with the period and the radius, we're going to want one of those AC formulas. Ideally, the one with period. Okay, so back to the pen and paper. Let's expand this out a little bit more and say that mass times centripetal acceleration, that's F net, right, is equal to Ft plus Fg. And realistically, if we want to get to one of our AC formulas, we're going to rearrange for AC. So finally here we can say AC is equal to force tension plus force of gravity, all divided by mass. All right, so that's fairly set up. I think we can see that once we have AC worked out here, we're probably going to work towards this 4 pi squared r over t squared formula. So anyways, let's solve for AC first. AC is equal to force of tension. The minimum force of tension at the top is, it told it to us, there it is, 20 newtons. Plus the force of gravity. Well, we have a mass of 2.8 kilos. And we're going to multiply that by 9.81 meters per second squared. And we can divide that whole value by the mass again, 2.8 kilos. That gives us a nice AC value here of 16.95 meters per second squared. Okay. Well, now let's jump into this AC formula. I probably could have laid this out a little bit earlier and framed the question a bit better, but I hope you can forgive me. All right, so the AC formula that we're looking for here, AC is equal to 4 pi squared r over t squared. We're looking for the length of this rod, which is the radius. Here is the radius for us to solve. Okay, we have t. We have AC now because we just solved it. And 4 and pi are just, absolute values, so they're not going to be changing anytime soon. We can rearrange this for radius, and we can figure out that radius is equal to AC times t squared divided by 4 pi squared. Okay. Realistically, we plug numbers in now and we finish this off. So radius is going to equal our AC, so 16.95 meters per second squared, times the period squared. That is 0.72 seconds squared. And don't forget that squared sign. These squared signs, they get people. They get them all the time. And it blows when you lose part marks on a test because you just forgot a silly square sign. All right, then we're going to divide this by 4 pi squared. And we get the final answer, a radius of 0.22 meters. I believe this question only has 2 sig digs, so we can leave it in that form right there. And put a box around it. All right, that's all there is to this one.